Welcome. We're all here because we build, train, and deploy machine learning models. We work with TensorFlow, we manage MLOps pipelines, and we understand the power of large-scale data. But as we push the boundaries of generative AI, especially in creative fields like music, we're running headfirst into a complex web of legal and ethical questions. This isn't just a topic for lawyers, it's a critical engineering challenge. Today, we're not going to skim the surface. We're going to do a deep dive into the technical underpinnings of AI music generation and unpack why it poses such a profound challenge to copyright law. Our goal is to understand the problem from a system-level perspective, so we can build more robust and responsible models. At the heart of every generative model is its training data. This is the genesis of the entire copyright problem. For music, this can range from well-structured academic datasets, like the LockMIDI dataset, to massive proprietary corpuses licensed from music labels. And then there's the gray area, vast quantities of audio and musical notation scraped from the public web. Now, as ML practitioners, we know that models like transformers or diffusion models don't just perform a lookup. They aren't simply copying melodies. They're learning the statistical relationships between notes, the structure of harmonic progressions, and the nuances of rhythm that define a genre. The model internalizes a high-dimensional representation of music. However, this creates a black box problem for copyright. Without access to the training set and weights, it's incredibly difficult for a plaintiff to prove their specific work was used to train a model that produced an infringing piece. This is a direct parallel to the challenges we've seen with large image models trained on datasets like Leon 5B. The scale of the data ingestion makes attribution and licensing a monumental task. The legal test for copyright infringement often hinges on a concept called substantial similarity. It asks whether an average observer would recognize that the new work was copied from the original. So, how does this apply to a non-human creator? The answer lies in the technical behavior of our models. The direct technical correlate to infringement is overfitting and memorization. A poorly regularized model, or one trained for too many epochs on a specific subset of data, can essentially memorize and regurgitate portions of its training set. This output isn't novel, it's a latent space echo, and it's the clearest path to generating something substantially similar. A well-generalized model, by contrast, creates novel compositions that are stylistically consistent but compositionally unique. The key challenge then becomes one of detection and mitigation.